Hey guys, this is Mr. C, and in this video we're going to solve some linear inequalities, and we're going to graph the solution sets. So the first one we have is t minus 45 less than or equal to 13. This is basically a one-step inequality, and it is less than or equal to. So all we have to do is really just add 45 to both sides. And so those will cancel out. And then we're going to get t less than or equal to, you just keep the same symbol, and then that would be 58. So that's pretty simple. When you graph this, I really only need to see one number on your number line, not a whole bunch of numbers. And generally we put that number right in the middle. So we're going to put 58 right in the middle right there. And it is less than or equal to. So what happens is you have either open circles or closed circles on your number line, depending on if that number is a solution to this or not. Well, if it could be equal to 58 with that little line right there, then we use what's called a closed circle, like this. And as long as the variable is at the left-hand side, we can use the arrow to determine which way we're going to shade. And so since the arrow is pointing to the left and the variable is over here on the left, then we can just shade over here on this side. And I usually just kind of shade like this. And then we just show a big arrow like that. And so what this means is, any number less than or equal to 58, when you plug it in for t right there, is going to give a solution to this inequality. So there's a lot of solutions, not just one, like for an equation. And to represent all of those solutions, which there's infinitely many, you have to use a number line to show that. Here's our second one. This one, the variable is on the right-hand side, so we're going to see what we need to do with that. I will go ahead and just add 4 to both sides to get rid of it, because you solve these just like an equation, basically. 7 plus 4 is 11, and I have 11 is less than x, but the variable is not on the left-hand side. So what I do is I take this whole thing and I kind of twist it all around like this, and instead I write x, and I flip the symbol greater than 11, and these two solution sets right here are exactly the same. Now some teachers are going to want to see this in what's called set builder notation. So if you have to use set builder notation for your solution set, all you have to do is write a curly bracket, and you write all x, the variable. That line means such that, that's like a condition, such that x is greater than 11, and then you just close it up with another curly bracket. So if your teacher wants it looking like that, then that's all you have to do, which basically you just take this, put a little line right here, and then curly brackets around each side. All right, so let's graph this. So we need 11 on here. Open or closed circle. Well, this one doesn't have the little equals part. So 11 is where you start, but 11 is not included in the solution set. So you have to put an open circle right there to show that. And then we are shading to the right because our arrow is now pointing to the right, and our variable is on the left-hand side. So we're just going to shade this side and then make a big arrow at the end, and we're done with that one. Okay, this one is looks like another one step. I would just subtract 19, and you get r is greater than or equal to 16, take away 19 would be -3. And so I just need to see -3 right there. It is greater than or equal to, so I am going to use a closed circle, and I'm going to shade to the right. Like this. And a big arrow at the end. So these can get a little more complicated. You could have variables on both sides, just like for equations. And so what I might do here is I might subtract 6p from both sides. Okay, so if I do that, I get 5 take away 6, which is actually -1p plus 7 greater than. And now since both of those canceled out and there's nothing left over here, it's actually a 0. So now I'm going to subtract 7, bring down my -p equals, not equals, oh, that's a bad thing, I shouldn't have done that. I'm so used to it, greater than -7. So I'm glad I made that little mental error right there to show you that that does happen. But I have a -p right there, so I have to divide both sides by -1. If you multiply or divide, and I'm going to say that again, multiply or divide, not add or subtract. If you multiply or divide both sides by a negative, you have to flip the symbol. And so now p is going to be less than +7. And so I need a 7 in the middle. It's going to be an open circle and shade it to the left. Can't believe I did that, but it doesn't surprise me because I've been doing a lot of work today, and that's just what happens. So just be careful. Like what I did right there, it's definitely not equals. All right, this one right here, we've got b over 7. And so these types of things are going to just start looking like equations. Like how would you get b by itself? Well, what I would do is I would multiply both sides by 7. Because 7 over 7 is 1. And I now have b is greater than or equal to 7 times 7 is 49. Okay, so now I just need a 49 down here, close circle. And since b is on the left, I can shade this way. And I'm just going to shade this way with a big arrow at the end. And now I'm done with that one. Okay, this one has a negative 2 over 5p less than negative 14. I'm going to actually rewrite this over here because I kind of didn't leave myself a whole lot of room over there when I made this. I could do that on the whiteboard, but I can't do it so well on here. So how do I get rid of a negative 2/5? Well, the most natural thing to do would be to multiply by the reciprocal on both sides. And so what I'm going to do is I'm going to multiply both sides by negative 5/2. Like that. And like that. Because if I multiply by a reciprocal, then that fraction is going to cancel out. And so now these two guys are going to cancel out because they're reciprocals. They make 1. P is less than, and now I have to figure out what this is. Now I did multiply both sides by a negative, didn't I? So since I multiply both sides by a negative, when I write that less than symbol, I'm really going to have to be careful with that because I'm not quite sure that it's going to be less than. So what I really need to do is I need to go ahead and scratch through that because, again, that happens all the time. And instead, I should really have p greater than. So because I multiplied by a negative right here and right here, now I have to flip the symbol. And that's something you're going to deal with a lot. And you're going to forget, and it just happens. So just cross through it, p greater than, and now I have to figure out what 14 times 5/2 is. Well, I know that 2 goes into 14 7 times, and I like to do it this way. 7 there and a 1 there. I like to cancel things out that way because it's just a lot easier. And I have negative 7 times negative 5, which is actually positive 35. So it doesn't look too complicated here, but if you're not careful, you can really mess it up. So we're going to put a 35 in the middle. We do have an open circle, and it's going to be going to the right shaded, like this. And then we're done with that one. The next one we have here is, we'll keep it simple, 14h greater than 95. And so what we might want to do is just divide both sides by 14. It's positive, so we don't have to flip the symbol. And we get h is greater than 95 over 14. Well, 95 and 14, you can't really simplify that. So let's see what we need to do. I'm going to get 95 divided by 14, and that's going to give me a it's about 6.78, about 6.8. Okay, so now what do I do? Because it's not an integer. Well, I'm going to put a 6 right here in the middle, and 7 would be right here, wouldn't it? And so sometimes you might have to put a couple numbers down here. 5, 6, and 7, that's really close to 7, and it's an open circle. So I'm going to put an open circle about right there. That's what your teachers are going to want. And then we're shaded to the right. And so we're going to shade. And so since it's not an integer, I just kind of have to put a couple extra numbers on there. That's no big deal. Okay, this next one should be fairly simple, but the first thing I see is I have a negative in front of my x. And so when I divide by negative 3, I got to be really careful because now I divided by a negative, so I have to flip the symbol. So these are going to cancel, but x is going to be greater than or equal to, and this would be negative 6. So now I'm going to put a negative 6 on here, right in the middle, closed circle, and it's going to be shaded to the right because that's the way the arrow is pointing, and the x is on the left-hand side, so I can do that. Not a problem. Here we have a good one. It's a it's a two-step. But if you remember this type of formula. It's kind of looking like temperature, like C would be Celsius. Not that we need to know that, but we just need to, we need to start moving stuff around. So I would not multiply by the reciprocal right yet because I have this 32 right here. So I'm gonna move the constant over just like I would for an equation. So if I move that constant over, now I'm gonna get 9 over 5c greater than, and then negative 31 minus 32 is actually negative 63. Now I am free to multiply by the reciprocal. So now I'm going to multiply by 5/9 on both sides. And luckily 63 is a good number because it's a multiple of 9. So these two guys cancel. Bring down my c, greater than. 9 goes into 63 7 times. And so I can actually cancel that out and put a 7 there. Cancel that out and put a 1 there. And 7 times 5 is 35, but it's also negative. So negative 35. And I did flip my symbol back here, or did I not? Well, I didn't really need to flip the symbol, did I? So if I look at my answer and it's negative, I asked myself, did I need to flip the symbol? Well, did I multiply by a negative? And the answer is no. So I did not flip my symbol this time, and that's fine. That's exactly what I'm supposed to do. So even though I subtracted by a negative, it doesn't matter. You have to multiply or divide by a negative. And that's worth mentioning as many times as I can. So negative 35 goes in the middle, open circle, and then that's going to be going to the right for my graph. Okay. Here we have another two-step, and so let's see how this one's going to shake out here. Again, you want to solve it like an equation. Subtract 19 on both sides, get rid of that. Bring down my negative 7b, still less than because I didn't multiply or divide by a negative. And negative 16 take away 19 should be negative 35. But now I am going to divide by a negative, aren't I? So when I divide by this negative right here, now I have to flip the symbol. So b is greater than, and 35 divided by 7 is 5. So b greater than 5 is my solution set. And so I need a 5 right here, open circle, and it's going to the right. And just shade like that. And then that one's done. Okay, so here we have one with variables on both sides, just like you would see with an equation. So I might go ahead and I have a choice. I really want to get my variables on the left. So I might as well just go ahead and subtract 5n on both sides. Those guys cancel. 3 take away 5 is negative 2n minus 18 greater than or equal to 21. And I do have a negative in front of the n, so I'm eventually going to have to probably flip that symbol. So I'm going to add 18 to both sides. I got now negative 2n greater than or equal to, and then 21 plus 18 would be 39. So now I'm at negative 2n greater than or equal to 39. So I'm going to divide by negative 2. I'm going to write n is less than or equal to, flip my symbol, and now 39 divided by 2, if you don't know, you can always just use a calculator. 39 divided by 2 is about 19.5. So negative 19.5. So now what do I need to do down here? I'm going to need a couple numbers. Let's put negative 20, negative 19, negative 18. And remember, your negative numbers get smaller, the number part, as you get closer to 0. So I got to put these on here correctly. And negative 19.5 would actually be right here. And it's going to be a closed circle. So I'm going to put a closed circle right there for negative 19.5. And I am going to the left because that's where n is. I mean, that's where the arrow is pointing. So my graph should look something like that right there. All right, so here we have another one with variables on both sides. So again, I'm going to subtract 9p on both sides just to get everything on the left for the variables. Even though it's a negative, negative 2p plus 11 greater than negative 13. So I'm going to subtract 11. Bring down my negative 2p greater than, and then that would be negative 24. Now I'm going to divide both sides by -2. And I'm divided by a negative, so what do I need to do? I need to flip the symbol. So that's going to be going this way now. And 24 divided by 2 is positive 12. Two negatives cancel. And so now I need an open circle at 12. And I could shade now to the left. And something like that. And then that looks good right there. All right, so now we're going to get some kind of weirder looking ones. So let's see how these are going to shake out. This one, and we may go over these in class and we may not. So these may be some just kind of extra stuff. You have 15 minus 2y over -3, and then you have this y over here. Well, what I would do first is I would multiply both sides by -3. And when you do that, this -3 is actually going to come around and it's going to go in front of the y. But I got to be careful because I just multiplied by a -3 to move that over. So I need to flip that symbol like this. And now I have 15 take away 2y over here. Now I'm going to add 2y. Okay, so now I have a negative y less than 15. So now I've got to multiply by -1. And so now look what happens. And now I have to flip the symbol again. And y is now greater than 15. So now I need a 15 right in the middle, open circle, shaded to the right. So I had to flip the symbol twice that time, and that happens because I had a negative here and a negative here. Okay, this one is definitely a multi-stepper here, so let's just go ahead and get through it. Let's go ahead and distribute. So 3d minus 8 times 2 is 16d. Then that would be a plus 18 is greater than 3. And then this minus will distribute to both these. And all that does is change the sign in front of them. Minus 2d and then minus 7. I can clean this side up a little bit. 3d minus 16d would be negative 13d plus 18. Is greater than. I can clean this up a little bit. A 3 and a -7 make a -4. I can put that in front or in the back. I'm going to put it in the back. Negative 2d minus 4. And the more math you get used to, the more confident you'll be in knowing that you can move things around and you can take these two numbers like -7 and 3 and put it here, or I could have put -4 minus 2d instead. You know, it's just experience. So now I'm going to add 2d. Because I always take care of the variables first. Negative 13 and 2 make negative 11. D plus 18 is now greater than -4. So I'm going to subtract 18 on both sides. And I'm kind of running out of room. I don't want to run into my number line. So negative 11d now is greater than negative 18 minus 4 would be a negative 22. All right, now I have to divide by negative 11. And so what do I do now? Flip the symbol. So d is now less than negative 22 over negative 11 is a positive 2. And so I just have a 2 here, open circle, and then I'm going to shade to the left like that. I need a bigger, wider marker, and that one's done. Okay, this time I've got a two-step equation, it looks like. I really need to add 13 to both sides first before I start messing with that 8. And I get w over 8 is greater than negative 6 and 13 would be a positive 7. Now to get rid of that 8 down there, I need to multiply both sides by 8 because the opposite of division is multiplication. So once I do that, these two 8's will cancel and I'll get w is greater than 7 times 8 is 56. And so it looks like I got a 56 in the middle, open circle, shaded to the right. Like that. All right, this time, I need to get rid of that 5 first. I can't do anything with this until I get rid of the 5. And so again, to get rid of that 5, I really need to, and I'm kind of running out of room here, but I need to multiply both sides by 5. That will definitely cancel this 5 out right here because that 5 is really in the numerator if it's written on the side like that. So these two guys cancel. So now I have 2a minus 3 greater than or equal to 7 times 5 is 35. Okay, so now I'm down to a two-step. Add 3, and this just becomes natural now. 2a is greater than or equal to 38. Divide by 2. And I have a greater than or equal to 19. And so I need a 19 right in the middle. That would be a closed circle because it has the equals part on it, and shaded to the right. Okay, this one, a little more complicated, so we need to, looks like, simplify this left-hand side and then simplify the right-hand side. And here's our symbol right here that kind of gets lost in there, doesn't it? So our symbol is less than. If you look at that thing, it's really confusing because you got all that stuff going on. So I boxed it in just to show you where it's at. So in an equation, this still is like a river, isn't it? You can only do stuff to this side or this side right now. So I'm going to distribute this 8, and I'm going to distribute this -3 first. So I'm going to get 8t plus 16 minus 3t, and then that would be a positive 12. I have to keep the same symbol now. I'll write that in red just to show you where it's at. Now the other side is going to become 5t minus 35. And it's still plus 8. Okay, so now let's clean this up a little bit. So now over here we have an 8t and a -3t, so that's 5t. We got a 16 and a 12, so that's 28, so plus 28. My symbol, I'll keep it in red here, still less than. And my other side, I can take the two constants and combine them. And so if I have a -35 and I add an 8 to that, I'm going to get a -27, so 5t, and that would be minus 27. All right, so now, if I subtract 5t on both sides, they both cancel. I bring down my 28 less than -27. So the variables canceled, and we've seen that before with equations when variables cancel. Did this leave a true statement or a false statement? Is 28 less than -27? And the answer is no, and that's false. So what does it mean when it's false and the variable's canceled? Well, that means my number line, I don't have any number that will work for that, none. And so we would write no solution for that. There's not even a graph you can show. This right here is basically done. You can't even do that. Or you can put the empty set because there's really nothing to show on there. All right, let's see how this one's gonna work. We have 3x plus 4 on this side. On this side, we can distribute the 2. So we would have 3x plus 4 less than 2x plus 6. And then plus another x at the end, don't forget that. We can clean this up a little bit. Now we have 3x plus 4 less than 2x and another one make 3x plus 6. Well, if I subtract 3x on both sides, those cancel, and I get 4 is less than 6. So again, my variable's canceled. And did it leave a true statement or a false statement this time? Is 4 less than 6? And the answer is yes. So this is true. Well, if that's true, then that means any number at all, any real number, I can plug in for that x, and that x, and this will be a true statement. So if your teacher wants you to actually graph that, that's a very simple thing to graph. You're gonna shade in the whole entire number line. The whole number line, because every number works. Now, I didn't put a number down here, did I? I mean, what would be a logical number, though, to put down here? Maybe 0, right? Because anything greater than 0, anything less than 0, even equals 0, everything should work. And so those are the kind of weird ones that they'll throw at you on the EOC and the state testing, that just to kind of see if you know how to handle it. Okay, so here we have one. It's just got a variable on one side, so that's good. And so I would add 2 to both sides, add 2, and I've now got -d/5 less than 23 plus 2 is 25. So I've got a choice. I'm going to go ahead and multiply both sides by positive 5 to see what happens. I know I'm going to have to get rid of it anyway. So if I multiply both sides by 5, what will happen? So let's see. Well, definitely for sure, these two 5s are going to cancel, but the negative is not. So that negative is still going to be with that d right there, less than, and 25 times 5 is 125. But I need a positive d. So I do need to multiply by, or divide by -1 here. And if I do that, we remember that we have to flip the symbol, and that would be a -125 now on the right-hand side. So I'm going to have a 125 in the middle, an open circle, shaded to the right. Okay, now, it is possible to get some problems with decimals on there. And if you get ones with decimals, generally, if the problem has decimals in it, they're going to want you to keep your answers in decimals. So let's just see what happens. We need to distribute. So 0.3x minus, and then 0.3 times 2 should be 0.6. So 0.3 times 2 is 0.6 minus 0.8x, because I didn't do anything with that, greater than 4.4. Over here, the only thing I can really do is take these two guys and combine them together. So if I take a 0.3 and a negative 0.8, that will give me a negative 0.5x, still minus 0.6 greater than 4.4. So now I'm going to add 0.6 to both sides, because I always get rid of the constant first. So let's work over here now. Negative 0.5x greater than, and then 4.4 plus 0.6 is actually 5.0. So now if I take both sides and I divide by negative 0.5, so now I have to figure out what 5 divided by 0.5 is, and that's going to be 10. But these two negatives are going to cancel, and I divided by a negative. So they are going to cancel, but since I divided by a negative, I have to flip my symbol, and that would be x less than 10. So I'll put a 10 in the middle, open circle, shaded to the left. Okay, got a couple more examples for you. I like a lot of examples. So this one, we got variables on both sides, so I'm going to subtract 7k, get rid of that. 13 take away 7 is 6, so 6k minus 11 greater than 37. I'm going to add 11, and I have 6k greater than 48. And so if I divide by 6, positive 6, I'm going to wind up with k, look how I did, I wrote 6, k greater than, and then 48 divided by 6 is 8. And so I need an 8 in the middle, open circle, shaded to the right, like this, and then that one's done. Okay, here I have one with some stuff in there. I could, and I have motion sensor lights, so let me go and make some motion out here to turn the lights back on. Here we go. Always fun thing. I knew that was going to happen. Let's go ahead and distribute this 3 right here first. So I got 3g minus 21 plus 9 less than or equal to 21. Now let's combine these two together. So I have a negative 21 and then plus 9, and then that's going to give me a negative 12. So 3g minus 12 less than or equal to 21. All right, let's add 12. And so now I have 3g less than or equal to, that would be 33. And we divide by 3. And so now g is going to be less than or equal to 11. So I have an 11 right here in the middle, closed circle, because of the little equals part right there, and shaded to the left. So if you're kind of weak on these equations like this, getting some extra practice with the inequalities is really a good thing, just to kind of reinforce those skills. All right, we got a couple more. So this one, what do I need to do first here? I need to get rid of the 2. And so when I get rid of the 2, and eventually you're going to kind of learn this, when you multiply both sides by 2, what happens is this 2 is going to wind up over here with this 10 multiplied by it. That's what's going to happen. And you're going to see that pattern. And you're going to get 3w plus 8 less than 10 times 2 is 20. So if you multiply both sides by 2, that's exactly what's going to happen. This is going to cancel out. And it's just going to move over there with the 10. Subtract 8. Subtract 8. So I have 3w less than 12. And we'll divide by positive 3. And so w will be less than 4. So I need a 4 right in the middle. Open circle. Shaded to the left. All right. This time, a little more complicated, especially over here. So let's pay attention to what we're doing. So we have 7 plus 3t less than or equal to, all right, so here we go. 2t plus 6. And now we're going to distribute this one. Negative 2 times negative 1 is positive 2. And negative 2 times negative t is a positive 2t. This side, we can't do anything with it, but we can clean this side up probably a lot. So 7 plus 3t less than or equal to, I got a 2t and another 2t, so that would be 4t. I've got a 6 and a 2, that makes 8. All right, so now I'm going to go ahead and subtract 4t on both sides. Because remember, with inequalities, I really want my variable to be on the left. It's going to have to be at the end anyway. So I have 7 minus 1t less than or equal to 8. So now I'm going to subtract 7, and I get negative t. I'm kind of running out of room here, but negative t less than or equal to, and that would be 1. But I really need that to be a positive t. So I'm going to divide by a negative, which tells me to flip the symbol. And 1 divided by negative 1 is negative 1. So I need a negative 1 right in the middle with a closed circle, shaded to the right. Just like that. And there it is. Okay, this time I've got to distribute both sides. So here's my symbol right smack in the middle. And I got to keep everything separated for now. So let's distribute this guy first. So 3 minus, definitely don't want to put 0 right there. Can't do that. That's not the order of operations. Negative 3b, and then that would be a positive 6, less than 13 minus, and teachers will do this to see who will actually put it like a 10 right here. But you can't do that. You have to distribute, don't you? So don't get caught doing that. Negative 3b, and then that would be a positive 18. We can clean some stuff up here. We have a negative 3b for sure, and then we have 6 and 3 make 9, so plus 9, less than. We have a negative 3b over here, which is interesting because we have it on both sides. So now something's cluing in. That's eventually going to cancel out. 18 and 13 make 31, so plus 31. Now if I add 3b to both sides, those both cancel, and I get 9 is less than 31. Okay, so is that true or false? That is definitely true. 9 is definitely less than 31. So if that's true, we saw already what to do when it happens. That's all real numbers. And so the entire number line gets shaded. 0 right in the middle. It's all real numbers will work. Just like for an equation. Except equations, yeah, well, I guess so. All real numbers. Okay, last example. Not so bad. This time we just need to distribute this left-hand side. Got 3n plus 7 times 3 is 21, greater than 5n minus 13. And so I'm going to subtract 5n on both sides to get the variable on the left. I got a negative 2n plus 21 greater than negative 13. Need to subtract 21, bring down my negative 2n, greater than, and that would be 34, negative 34. So I'm going to divide by negative 2, and we all know what happens when we do that. N is going to be now less than 34 divided by 2 would be 17, and so positive 17. And so we'll put a 17 in the middle, open a circle, and then shade it to the left. All right, guys. Well, that's a lot of examples on solving linear inequalities. Remember to like my video and subscribe to my channel, and we'll see you guys later. Bye.